Now, we are not going to use the unit circle really after this in this unit, but I want to graph the sine and cosine curve, and the values of the graph actually do come from the unit circle. So I'm just going to pull the unit circle in for just this one part. If you look at the next pages, there's no more unit circle, all right? So, did anybody remember the unit circle from over the weekend? 3, 2, 1, 1, 2, 3, all right? All denominators of 2. All right, so 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. All denominators of 2.
Go for the 2 over 2 the square root at the top.
Yup, and the 3s.
And the 3, yeah.
All right, so there's our coordinates there. What about our corner coordinates? Like these, what do they have?
0, 1.
Zeros and ones, right? So this one is a 1 and a 0. This one is a 0 and a 1. This one's a negative 1 and a 0, and a 0 and a negative 1. All right? The other, and you don't even need to write tangent. We're not going to graph tangent. Tangent is like a really funky looking graph. So we're not going to, tangent is filled with asymptotes. Okay, so we're only going to graph sines and cosines. So you don't even need to remember the tangents here. We're just going to fill in the other thing, which is the angle. So it's 30. Anybody remember what that angle is? The middle one? 45 and 60. And then radians, pi over 6, pi over 4, and pi over 3. And then our corner ones, 0, 90, 180, 270, back to 360. 0 and 360 are the same. Radians, that's 0, pi over 2, or some of you would call that 0.5 pi, whatever works. Pi, 3 pi over 2, or 1.5 pi, and then back to 2 pi, right? So we're going to use like this portion. Now we're going to, instead of graphing it as a circle, we're going to graph it on an XY plane so that we can actually see what it looks like as a graph, all right? So when you are wanting to graph something, having a table helps. So what I did was I pulled what I think to be like the critical points of the table. These are called the turning points of the table, and they happen on the corner points. So does anybody remember from last week, sine is X or Y? Y. Sine is Y. So if I want to fill in this table that's on your toolkit, I'm going to go to 0 degrees, or 0 radians, and to find the sine, I'm going to look at the y value of that coordinate point, right? So here is 0 degrees, here's the coordinate, so sine of 0 degrees is the y value, which is 0. So if the x is 0, the angle is 0, then the y value is 0, the sine is 0, right? The next angle I have is pi over 2, which is 90 degrees. So if I go up to my 90 degree coordinate, and I'm looking to do the sine, sine is y, so the sine of pi over 2 is the y value at pi over 2, which is 1. Everybody see how I'm getting these values so far? So if I was doing the sine of pi, what would I write? What's the y value at the angle pi? 0. All right, going down to the next angle. I'm just going over 90 degrees at a time. So 3 pi over 2 is my next angle, and the sine of that angle is -1. The y value down here is -1, and then 2 pi puts me right back to where I started. So I'm just taking these because these are easier to graph than like a root 3 over 2. If I asked you to graph a root 3 over 2, you would definitely need your calculator to know what that is. If I asked you to graph a 1, you shouldn't need to use your calculator to graph that. So I'm just picking the ones that are nice and clean so that when we go to sketch this graph, I don't have to use a calculator, even though you can. You wouldn't necessarily have to, all right? So now that I have this table that I created, I can graph it, all right? So you have a graph on your paper, and we're going to graph it. The x-axis is the angle, so I'm going to go up by pi over 2, which is really like 1/10. 1, 0, 1/2, 1, 1.52. It's going up by pi over 2's. So on the x-axis, I'm going to label 0, pi over 2, pi, 3 pi over 2, 2 pi. On the y-axis, I'm just going up by 1s, right? So I don't need to do anything like radian-wise here. My y values are 0, 1, and negative 1. So I'm just going to call this 1 and 2, negative 1, negative 2. Just going up by 1s for y's because the y's aren't radians. The y's are coordinate points. And they were whole numbers. So now I just have to plot the points. If x is 0 and y is 0, then that first point happens right here. If x is pi over 2, the y value is 1. So that point's right here. 0, 1. If x is pi, then the y value is 0. So pi comma 0 is right here. 3 pi over 2, negative 1. And 2 pi 0. If you connect these, this is what the sine curve looks like. It kind of looks like two parabolas put together. It's like the u parabola and then the upside down u parabola. Right? You can use a calculator to graph the sine curve. You don't have to memorize this. So like if you didn't know what to plot, you could just go to your y equals screen and type sine of x. Like your calculator doesn't have a theta, right? Like the question says, but you could do sine of x and you could hit graph and see like what the curve looks like. My window must be weird. I'm gonna change it to negative, or sorry, my x min was 0 in my table, right? That was the first x value, and my x max was 2 pi. That was the biggest value for the x. And then it was going up by pi over 2. You don't even really need to change this to see the graph, but I'm just gonna do it so it looks consistent with what you see on your paper. On my table, I had, or on the graph that was given to me, it went from negative 2 to positive 2 by 1s. What am I missing that that's not showing? 0, 2 pi by 1s. Maybe I'll just make it smaller. I don't know why that's not graphing. You know what? Maybe that is what it is. Oh, look at you, Garrett. Is that Garrett? Should give you like an extra point on the quiz or something. That was good. I wasn't in radians. Alright, so now you can see it's exactly what it was. Alright? So you don't have to memorize that. I guess just make sure you're in the right mode. If it was 0, 90, 180, then I'd be in degree mode. I think you'll find that it's not too bad to do without a calculator, but again, you can have a calculator. It's not a big deal. Alright, so now that we have that graphed, we're going to do the same thing, but we're going to do it with cosine. Alright, so this was the sine one. We're going to look at that same unit circle, and as we go around the unit circle, we're going to look at the x values rather than the y values because cosine is x. So at the unit circle, at 0 degrees and 0 radians, the x value is what? What's the x value at 0? Well, it's 1, 0. So the x value is 1. So the cosine at 0 is 1. At pi over 2, up at the top, 0, 1, the x value, because cosine is x, is 0. So I'm going to do 0 here. And as we go over, pi is negative 1. 3 pi over 2 is 0. And 2 pi's back to where I started is 1. So I'm going to graph this one. Going on the x-axis, the x scale is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And on the y, I'm just going to go 1, 2, negative 1, negative 2. So now I can take the values from the circle and put them on the graph by plotting points. So 0, 1 is here. Pi over 2, 0 is here because I'm not going up or down at all. Pi goes to -1. 3 pi over 2 is 0, not going up or down at all. And 2 pi goes back to 1. Cosine looks a little different. So I'm going to kind of go back to what Will said earlier. He's like, are we going to have to remember her punch again? Here's what is helpful to remember, but you don't have to because remember you have a calculator, okay? But what's helpful to remember is the difference between sine and cosine, which is 5 values. It's a pattern, okay? So the 5 critical points of sine, so just going back one to sine. The 5 critical points of sine, this is helpful to remember. You don't have to memorize it, okay? Is 0, 1, 0, -1, 0. Those are the critical points of sine. It's the order that I went, right? Sine starts at 0. So the critical points of sine are the turning points, okay? It's when they change direction. The critical points of cosine are the same numbers, but in a different order, okay? So cosine is 1, 0, -1, 0, 1. Just the way we go around the circle for the x's and the y's, all right? So throughout the unit, I'm going to leave these up here. I'm calling them the OG sine and the OG cosine. We're always going to come back to these tables. 0, 1, 0, -1, 0. 1, 0, -1, 0, 1. All right? So these are the original tables. We've created them with the unit circle. What we're going to do is we're going to move these tables left and right. We're going to move these tables up and down. We're going to make them go faster. We're going to make them go slower. We're going to stretch them and make them taller. We're going to shrink them and we're going to make them skinnier by doing different things to the equation. When we do different things to the equation, it will do different things to these numbers, but we'll always come back to these numbers. Like these are the originals. So today what we're going to do is we're going to focus on what's called the amplitude, okay? Amplitude is the stretch and shrink of the curve. So an amplitude is going to take this curve and make it either taller or shorter, okay? So it's like a vertical stretch, we'll make it taller, a vertical shrink, we'll make it shorter. So on your toolkit page 3, you've got this new vocabulary. Amplitude is the height of the graph, okay? So amplitude is half the distance from the min to the max. I don't need you to know the definition of amplitude, okay? In an equation, we're going to do 4 different things in this unit. The A will do something to the graph, the B will do something to the graph, the C will do something to the graph, and the D will do something to the graph. Amplitude is the A. So if I say, what's the amplitude of the graph, all you have to do is look at the number in the very front. Amplitude is A. Right? If I'm using that general equation. And amplitude is going to give us a vertical stretch and compress. So think about like vertical, like if I have like slime in my hand and I vertically stretch it, it gets skinnier and skinnier but longer and longer. And if I have slime in my hand and I vertically compress it, I push it down, it's going to get wider and shorter, right? So that's what the graph's going to look like. So a vertical stretch is going to happen when the A value is greater than 1. If I have a 2 in the front, it's going to make the graph 2 times taller. If I have a 5 in the front, it's going to make the graph 5 times taller. Which kind of should make sense. If I have a 5 in the front, I'm multiplying all the values by 5. It's going to make them 5 times bigger, right? A vertical compress is going to be between 0 and 1. Basically, you're looking at an improper fraction, okay? a reflection, what that is like when you think about like looking at your image in like water, right? It takes me and it puts me down there. So like a reflection's gonna take a U and it's gonna flip it. Okay, it's gonna take an upside down U and it's gonna flip it. So a reflection just changes the direction of the graph, all right? A reflection is gonna happen when A is less than 1, okay? It might help for you to just write negative. Right, if you have a negative in front, that's called a reflection. Now all of these things are vertical changes. Vertical is up and down. What axis is up and down?
X, Y.
Y. So what's going to be changed about the OG is the Y values, because vertical is up and down, so the Y values are going to be affected. So it says, since amplitude is a vertical change, it affects the Y values. A vertical change is going to do nothing to the 0, pi over 2, pi, 3 pi over 2, and 2 pi, because that's X values. That's a side-by-side change. Vertical stretch is an up and down change. So what's going to happen here is we're going to change these values based on what the A is, all right? And it's going to be different for all of the problems. So let's look at your first example. It looks like this. It's 3 sine of x, all right? 3 sine of x. Every single time I get a table like this, what I do is under the table I write the OG, the original sine critical points. Sine's critical points are 0, 1, 0, negative 1, and 0. That's sine of x. I want 3 sine of x, right? So what do you think I'm going to do to those numbers? Times 3, right? So 3 sine of x is going to be these numbers times 3. So I'm just going to multiply each of them by 3, and this is going to give me my new table. 0 times 3 is 0. 1 times 3 is 1. Sorry, 3. Horrible math. 1 times 3 is 3. 0 times 3 is 0. Negative 1 times 3 is negative 3. 0 times 3 is 0. Did I lose anybody so far? Now, if you just wanted to see this, like, here's sine of x, versus here's 3 sine of x. I'm just going to change my window a little bit because I'm only going from 1s, so let me just make it 5s. So the blue is sine of x, and the red is 3 sine of x. See how the red is taller? Yes? I call that a stretch, right? I'm stretching it out. I'm making it a taller, like think of a person that's stretched. They're taller, all right? So the way that I describe this in terms of a transformation, it's taller, which means it's a vertical stretch because it's up and down. It went higher up. So when I describe my transformations, I'm going to call this a vertical stretch. You can say of 3. Mathematically, the correct term is by a factor of 3. But a vertical stretch of 3 is fine with me, all right, as long as you know it's a stretch. The reason it's a stretch is it's getting taller. You can see that in the graph. And the reason it's getting taller is because the A value is bigger than 1. It's greater than 1, all right? So the amplitude of this graph is 3. The amplitude is determined by that multiplication factor. We just made the max height now 3 when it used to be 1. Right? The tallest part of the graph is now at a 3. Easy enough? All right, let's look at the next example. Negative 1/2 cosine of x. First thing I need you to recognize is it's cosine and not sine anymore. So when I use my critical points, I want to use the OG cosine ones, not sine. All right, so they're different, the bottom values. So now the bottom values are gonna start at 1. 1, 0, negative 1, 0, 1. Because when we went around the unit circle, that's what we got for the x values, the cosine values. Everybody okay with that part? Look at the trig function. The sine is gonna have values written on the bottom. Cosine's gonna have different ones, all right? Now, what am I gonna do to those values? I want them to be multiplied by, these are the original, negative 1/2. So my multiplier is negative 1/2. I was using the same, but 1 times negative 1/2 is negative 1/2. 0 times negative 1/2 is 0. Negative 1 times negative 1/2, that double negative, is positive 1/2. 0 times negative 1/2, 1 times negative 1/2. So if I wanted to see what this one looks like, because you don't have to have any of these descriptions memorized, right? I would, in y1, put cosine of x, because now I'm working with the cosine. And in y2, negative 0.5 or negative 1/2 cosine of x. Remember, the original's going to be blue, and the new one's going to be red. They're color-coded like that. All right, so the difference, it looks like they started at opposite places. This is the reflection, like this flipped. This went down and this went up. That's the reflection part. And then you can't really tell that it's shorter because it's so much little less shorter, but like this is 1 and this is between 0 and 1. So it did shrink in terms of that. It's just harder to see when it's like this. If I took the negative away, it would be a little easier to see. When you see them like kind of on top of each other like that. Okay, so that is called a vertical because it's up and down, compress because it's getting shorter. And the flip part is called a reflection. So in the description, I would say reflected over x-axis. So the negative does that. And then the 1/2 does a vertical compress. You need to write the word vertical because tomorrow I'm going to show you what a horizontal stretch and compress is, and that's different. So you need to make sure you write the word vertical. So it's a vertical compress. I'm going to say by a factor of, but you can just say of. You don't have to write all this part out. It's not a vertical compress of negative 1/2. The negative does one thing and the 1/2 does something different. So I'm like separating them. The negative is the reflection, the compress is the 1/2. The amplitude is 1/2. Amplitude is height. You can't have a negative height, all right? So the amplitude is 1/2. It's not negative 1/2. The negative is the reflection piece. The amplitude is the number. You okay with that one? All right, I'm going to have you guys try 2 and 4, and then we'll go over the solutions. Make sure you're using the right original function. If it's sine, use the sine 5 values. If it's cosine, use the cosine 5 values. You're trying 2 and 4 out.
For this one, you want to put the negative in front because you already said reflected.
Oh, there's not a 2. Is there a 2 and 4? Why is that labeled 1, 2, 4, 5?
Oh, I did this all wrong. Oh my god.
Just read it. Work on it and do this. That's this one, right? A is less than 0. You're right. Your nose should say 0. Not a dumb question, a smart one. 0. It would have to be negative. Yeah.
Because I was asking if it was in between the two.
No, if it's in between, that's the compressed part. It should be 0. That should have been 0. A spider? I'll kill him for you. It's alright, people don't like bugs, I get it. I have 3 boys, and my husband is scared of spiders. Maybe police detective, but is scared of bugs. Because it's less than 1, it's going to be a compressor. It's going to make it a fourth shorter. Because this is between 0 and 1, right? So it would be a vertical reflective or the vertical stretch is
The reflected one is the cross.
the reflected is the negative. If there's a negative in front, that's where the reflections come in.
Okay, that actually is right there. So this vertical stretch.
Correct. 1/4 is going to make it shorter. Right?
So it's opposite.
It's not, yes, it's the number, right? If the number is greater than 1, then it's a stretch. If the number is somewhere between 0 and 1, it's a fraction. That's it. You did look at it, look. So, I'm gonna change your window to this. I changed it. 0, 5 over 2.
I had a hot dog. That was actually hard. There were Chick-fil-A nuggets.
See how the blue's shorter? That's what it's compressed. I'm pushing it in.
I'm gonna do it again next. I actually went in for it.
This is like
I think so, yeah.
look at this highest point.
It's
Look at this highest point.
I really like
It's
it.
shorter. Right? If this was instead of 100,
It's still young.
now it's taller. See that? And so what I see from the blue is I stretched it. I moved it this way. Whereas when I do it, then it's stretched, it's bigger, the red's down. You're comparing it to the original. Yeah, you might just need to adjust your window. So 0, 2 pi. You won't have to adjust this part. Okay. Because it'll here's the pi over 2. And then
So
so sine will be what you see first. Here's the original. And then the next one will be the other end. See how it's shorter? Shorter is like that's the compressed. If it's taller, like look, you can change the number 1/4 to a 4. Get it original. And now taller. That goes higher. That's the stretch. Versus the compressed. Reflection is the negative in front. How you see it is your critical points will become opposite. So instead of 0, 1, 0, -1, 0, -1, 0, positive.
So like what this, it's like this is cosine,
That was the original. Yep. Yep, just that. It's always reflected over us. We don't do a lot of
or I
reflection.
don't know if it's like. I could do this one.
Reflected, yes. This is not a compressor, it's a
But it
stretch.
was like funny, like it's just
Reflected. This one's good. You have compressed. This is a stretch because it's the 5. This is compressed because it's a fraction. Yes.
Okay, and then vertical compressed only like if it's a fraction.
function with no transformation. If it's just cosine, it's just that. There's no transformation.
Okay, and how do I write reflect over x over like how do I write
You can write, we just change your word compress to stretch.
okay.
Alright, so number 2 is cosine, right? So I'm not even looking at the numbers, I'm looking at the cos. If I'm looking at the cosine, I want to make sure I'm using the original cosine values. The 5 critical values of cosine are 1, 0, -1, 0, and 1. Alright? And this is -5 cosine. So I am taking the cosine and I'm multiplying it by -5. So I'm going to multiply all the values by -5. That's going to give me my new table. So 1 times -5 is -5. 0 times -5 is 0. -1 times -5 is +5. 0 times -5 is 0. 1 times -5 is -5. In terms of what's happening with the equation, the negative does one thing and the 5 does something else. You treat them as 2 separate pieces, right? The negative is causing what's called a reflection. And I'll show you what that looks like, all right? So if I am reflecting it over the x-axis, here's cosine of x. Here's what the reflection piece does. It like takes this and reflects it. So like this is like the water. This is the reflection you're looking at. It's flipping it down. Okay? So it's flipping this part on the other side. Okay? That's the reflection part. The 5 does something else. So I'm going to change this to a 5 just so you can compare it a little bit easier. So the blue is the original, the 5 is taller. Do you guys get what I mean when I say taller? Like, does that make sense to you? The red is higher up than the blue. The taller is called a stretch. It's like when you're pulling something. A compress is when you're pushing it down and making it shorter. So the fact that it's taller means that the 5 is going to stretch this out. So in my description, I would call the 5 a vertical because it stretched it up and down. And this is a stretch. By a factor of 5. Not -5, 5. The negative is the reflection. Are we okay with that piece? The amplitude is the height. You're not going to tell anybody that you're -4'11". That doesn't make sense. Heights are negative, okay? So the height, the highest point of the graph is my 5. The amplitude is the number. It's not the negative. Amplitude is like an absolute value. You're not looking at it in terms of negatives. All right, we okay with that? That one? All right, let's look at the next one. All right, now the difference here is now it's sine. So I want to look at the 5 critical points of sine. That's the one thing that you're going to practice remembering, all right? The order of the sine. So sine is 0, 1, 0, -1, 0. Cosine is different. The 5 critical points are different, all right? For this one, I'm taking sine and I'm putting a 1/4 in front. So I am multiplying it by 1/4. All of these values are going to get multiplied by 1/4. So I get 0, 1/4, 0, -1/4, 0. You can know what that transformation does, and eventually you'll do enough that you just know, but you don't have to just know, you can look. All right, so my original function is sine of x, and my new function is 1/4 or 0.25 sine of x. Oops. So look at the blue compared to the red. The red got shorter, and we call that a compress. Okay? The reason it compressed is because of the fraction. If this was a 4 instead of a 1/4, now it's getting taller, okay? So the whole numbers, the bigger than 1 numbers make it taller, that's a stretch. The fractions are little numbers, they make it compress. So when I'm describing this one, I would call it a vertical compress by a factor of 1/4. There's no reflection here. In order to have a reflection, what would I need? A negative. Then that's different, but there's no reflection here. My amplitude is just the height of my graph. The highest height of my graph was 1/4. I'm getting that directly by whatever number's in front. Amplitude shouldn't be negative though.
Can you say stretch or compress, or you have to say compress?
You would have to say compress. So the stretch is if the number is greater than 1. The compress is if it's less than 1.
Oh, okay.
Fraction is a compress. Greater than 1 is a stretch.
Thank you.
Yep. That's all I have for you today. Are you guys okay with that?
Oh, perfect.
I don't want to throw too much at you at once. Plus, we've got a little bit of time. So tomorrow we'll do horizontal stretch and compress, which is a little harder because horizontal is x values, which means we're going to be working with the pi's rather than the 1s and 0s.
So then we'll have the zeros and we have to work 2 pi.
So think about how we multiplied all of my y values by 4. We're going to do that too, but we're going to multiply the x values by that. And now you're working with pi and 2 pi. So the pi complicates your math, not the problem. So we'll do the x values tomorrow.